Welcome, learners! If you click on the video, it means you are wondering about our group's virtual box. Fear not, wonder of science leads to more discovery. So let's make sure curiosity is replaced with knowledge. Let us begin the exploration.
Before we get started, I had like to introduce our group members, so we all know who's who. First thing first, my name is Aimini. Next, we have Yuni, Adila, Amira, Shafika, and lastly, we have Ain. This is all my group members.
Optical instruments bring wider view in creating new device and exploring the phenomenon of light, in which contribute to significance of developing new technologies. Studying the behavior of light increase the availability in connecting with other various subjects, including astronomy, physics, chemistry, and biology.
So let's proceed to feature per analogy. Refraction involves the bending light, and the principle applies to lenses that are used in manufacturing optical devices in daily life. Lenses provide the essential way to operate light in solving complex visual problems, allowing to correct vision, magnify small objects, and focusing light.
Before we dive deeper into the VR box, I had like to provide you with a brief description of our project. A VR box is an affordable and straightforward device designed to convert a standard smartphone into a virtual reality headset through the use of customized lenses that improve their visual experience. This unique device allows users to immerse themselves in three-dimensional worlds. The VR box normally comprises of a strong frame that holds the smartphone firmly in place. This frame is commonly constructed of cardboard or plastic. Users can experience the feeling of being there in a virtual environment by exploring a range of virtual landscapes, engaging in interactive games, and watching 360-degree video by downloading compatible VR application or content. The power and adaptability of contemporary smartphones paired with the VR box simplicity make it useful and affordable virtual reality portal for a broad audience.
In this configuration, I will be informing the scientific details. The terms refraction and lenses have already been mentioned previously, so I will further explain about them. Refraction happens when light travels at different speeds in different optically transparent materials. For example, a source of light striking a prism. The ray of light travels from air to the glass. Light rays do not travel in a straight line across the boundary but changing in direction. The observable result would be seeing the light bending. Snell's law is applied to this phenomena, in which the equation being n1 sin theta 1 equals to n2 sin theta 2. N will be the refractive index, and the theta is the angle when the light enters and emerges across the boundary. Light passing into the second medium bends through an angle with respect to the normal to the boundary. Thus, the greater the refractive index, the greater the bending of light. Moreover, the lenses. For converging light, the convex lens is used. In VR box, biconcave lenses are utilized in it. The extent of the refraction and focal length are determined by degree of curvature and material of the lens. Now for the image formation. Seen through the convex lens, the light rays from the source is refracted to form images that appear larger. The characteristics of the image differ with changing the distance of the object to the center of the lenses. Some images would appear bigger or smaller, upright or inverted, or even the same size. Hence, sense of depth and immersion are stimulated by having proper alignment of the eye with the lenses.
Now, we know about the scientific details, so we can proceed by understanding it in real-life phenomenon. A real-life phenomenon analysis to virtual box can be found in the concept of sandboxing or content environments in various industries and contexts. The first one is training and education. Virtual environments are commonly used in training and education programs to simulate real-world scenarios in a safe and controlled manner. For example, Medical students may use virtual simulation to practice surgical procedures, and IT professionals may use virtual labs to learn networking concepts or test new technologies. Next, virtualization technology is also utilized in gaming and entertainment industry to create immersive virtual worlds and simulations. Virtual reality technologies allow users to interact with digital environments and objects in a realistic way. The last one is about cloud computing and infrastructure management. Cloud computing platforms often leverage virtualization technology to provide scalable infrastructure services to businesses and individuals.
We are going to break down the steps to create our very own VR box. Firstly, we will need sturdy cardboard, whole circular shape cut out from the curved part of the clear plastic bottle, scissors, super glue, hypodermic needle, marker pen and cellotape. Next, use the two circle shape cutout to make one convex lens. Stick the two cutout together with each side facing out, resulting in convex lens shape. Apply a thin layer of glue around the outer edge, leaving the center unglued. Leave a small hole to add water later. Be careful not to apply too much glue, as excess glue can squeeze out and affect the clarity of the lens. Gently press down your circular pieces to ensure a secure bond with the glue. After the glue has fully cured, add water into it by using hypodermic needle and make sure the glue remained full after water was added. Now, you have your own DIY convex lens. Next, start by measuring and cutting out the following cardboard pieces. 2 rectangular pieces for the main body of the headset, 1 smaller piece for the divider between the eyes. Fold the 2 rectangular cardboard pieces to form a box shape, leaving one end open for the screen. Glue the edges together securely. Then, attach the smaller cardboard piece inside the box to separate the eyes. Carefully cut out holes in the front of the box to fit your lenses. Place the lenses into the holes, ensuring they are positioned at the right distance from your eyes for a clear view. Finally, insert your smartphone into the open end of the box, making sure the screen is facing the lens.
Next, we move to discussion and analysis. In our product, we got lens system which contains a pair of lenses positioned between the user's eyes and the smartphone screen. These lenses are typically convex lens. It helps to converge light rays, allowing the user to focus on the screen while maintaining a comfortable viewing distance. In terms of magnification, the lenses used to magnify the image displayed on the smartphone screen. This magnification is necessary to create a sense of depth and immersion in the virtual environment. By enlarging the image, the lenses make it appear as the virtual objects are closer to the user than they actually are. In our product, we also got field of view, which is the curvature and design of the lenses determine the field of view. A wider field of view provides a more immersive experience by allowing the user to see more of the virtual environment. The last one is light blocking. It is very important for our product to have it since it helps to enhance immersion in the virtual environment. We use a black pepper to prevent light from entering the viewing area. For better understanding, a ray diagram is prepared. Light from the phone is converged into our eyes. By using 2 lenses, stereoscopic image would be produced due to the brain perceiving the images as 3-dimensional effect. Hence, the illusion of depth is created.
In conclusion, the application of a VR box is deeply connected to refraction, leveraging it to create a realistic and comfortable viewing experience by manipulating how light is spent and focused by the lenses. This involves precise optical engineering to ensure that the virtual environment appears immersive and natural.